Surprisingly, contrary to expectations, new revelations indicate that parts of S-31 on the other side of the world are the first Starship components to be recovered. What's next? Meanwhile, SpaceX has achieved an incredible milestone with Falcon 9. Next, we'll dive into the details of China's ambitious plan for its first crewed mission to the moon. Let's explore all of this on today's episode of Great SpaceX. It's been 2 weeks since Flight 6, and while anticipation builds for the next mission, there's also significant interest in the recovery efforts for Flight 6's key components, Booster 13 and Ship 31. Both achieved what are considered successful landings, sparking curiosity about their current statuses. For B-13, we've shared numerous updates in previous episodes, and it seemed logical to assume it would be recovered first. However, that assumption was mistaken. While updates on B-13's recovery have been scarce, significant progress has been made with S-31. Thanks to my partner Interstellar Gateway, we now have a wealth of images and videos providing insights into S-31's recovery. I'd like to take a moment to thank their team for their dedication and exceptional work. Their efforts have allowed us and the broader SpaceX community to gain a better understanding of this complex process. If you're watching this, consider giving their team a follow on X and subscribing to their YouTube channel to encourage them to continue producing high-quality content. The recent published images reveal key components of S-31, including its COPV tanks and heat shield tiles. This evidence suggests that while S-31 achieved a remarkable landing, it was not entirely intact. These parts were recovered by the Limitless ship, which returned to port in Australia on November 23rd, just 4 days after Flight 6. Before the mission, Limitless and its companion ship Bhagwan Renegade were deployed from Australia to the planned landing site. Their initial role was to record S-31's landing in daylight conditions. After the landing, the vessels monitored the ship for approximately 27 hours before commencing the recovery process. Analyzing the hardware, the images show between 4 to 8 COPV tanks in excellent condition, demonstrating their potential for reuse in future missions. Additionally, a bag containing heat shield tiles was recovered. Observations indicate that these tiles, particularly those from the nose cone, remained remarkably intact, highlighting the effectiveness of SpaceX's recent upgrades. Based on footage of workers inspecting the tiles, it appears that they were glued rather than pinned, a design choice that may have contributed to their resilience. Other components have also been recovered, but they remain tightly packed, making their specific identities unclear. Once these parts arrived at Exmouth Port in Australia, they were loaded onto trucks and transported to an initial research facility. It's likely they'll eventually be sent to Starbase for more extensive study. The data collected from these components will be invaluable in refining future prototypes. Despite these successes, the goal of recovering S-31 as an intact vehicle was not realized. When Renegade returned to Onslow Port, Australia on November 24th, it was equipped with a fender designed to help tow intact ships, but carried no trace of S-31, not even debris. This suggests that the attempt to recover S-31 as a whole was unsuccessful. However, large sections of S-31 may still be salvageable. Based on its post-landing conditions, it's reasonable to hope that components like the nose cone or the aft section, which houses the payload bay, flaps, and engines, could still be recovered. The presence of unloading facilities at the Australian port further supports this possibility. Looking ahead, we're eager for further updates from SpaceX about how S-31's parts will be returned and studied. Similarly, hopes remain high for B-13's recovery, especially given its closer proximity to SpaceX's operations compared to S-31. If recovered soon, B-13 could play a significant role in advancing Starship upgrades. In the broader context, SpaceX's SpaceX's recovery progress is laying the foundation for full reusability of Starship. Future missions will likely bring SpaceX closer to its goal of towing entire ships back to land for reuse. Flight 7 is expected to include another ocean landing, providing an additional opportunity to refine recovery methods. If successful, this could pave the way for SpaceX to attempt catching ships directly with the tower, a milestone confirmed by Elon Musk. We will do one more ocean landing of the ship. If that goes well, then SpaceX will attempt to catch the ship with the tower. If you share our excitement about SpaceX's advancements, reply yes in the comments. Don't forget to like and subscribe to our channel to stay updated on SpaceX's development journey. Your support has been instrumental in helping us surpass 153,000 subscribers, a significant milestone. However, we've noticed that many viewers have not yet subscribed, so we encourage you to join us as we aim for 200,000 subscribers before the new year. Your support not only motivates our team, but also ensures you receive timely updates about SpaceX and the aerospace industry. Together, let's continue to follow SpaceX as they push the boundaries of what's possible in space exploration. Thank you for being part of this incredible journey. On November 26th, at precisely 11:41 p.m. Eastern, SpaceX achieved another monumental milestone with the Falcon 9. Launching from Launch Complex 39A in Florida, the mission deployed 24 Starlink satellites into orbit. Just over an hour after liftoff, the satellites were successfully released, marking another flawless mission for the Falcon 9 and adding to its incredible legacy. This launch was particularly significant because it represented the Falcon 9's 400th successful mission. SpaceX triumphantly highlighted this milestone on X, posting, "Falcon 9 completes its 400th successful mission and Falcon's 375th overall landing. This achievement underscores SpaceX's unmatched dominance in the rocket industry, as 400 successful launches surpass the total flights of most other current rocket families. It also sets a new standard that will be incredibly challenging for any organization to match in the foreseeable future." The Falcon 9 achieved its 400th overall launch on November 24th, just 2 days before its 375th booster landing. This milestone highlights SpaceX's unmatched launch cadence and operational efficiency. While delays from the FAA and weather conditions postponed the 400th mission, the progress remains extraordinary, fulfilling predictions made after the rocket's 300th launch and landing milestones last year. With 1 month left in 2023, SpaceX has more opportunities to extend Falcon 9's record. Looking forward, the pace is expected to quicken in 2025, potentially allowing the Falcon 9 to reach its 500th successful mission by mid to late 2025. This would further solidify SpaceX's reputation for groundbreaking achievements in space exploration. To sustain and surpass its milestones, SpaceX must focus on system upgrades to ensure stability and reliability. The incidents in July, August, and September, while not failures, underscore the inherent challenges of frequent rocket launches. These events emphasize the need for constant refinement to maintain high-frequency operations. SpaceX's iterative approach to innovation is well suited to address such challenges, paving the way for even greater efficiency and reliability. Recently, SpaceX celebrated a major achievement, the Falcon 9's 375th successful booster landing. This milestone reaffirms the company's dominance in rocket reusability, a field where it continues to outpace competitors. As SpaceX proudly announced on X, Falcon 9 has landed, completed our 375th overall recovery of an orbital-class booster. Rocket reusability remains a hallmark of SpaceX's innovation, with unmatched consistency and reliability. Having achieved 375 booster recoveries to date, the company is poised to reach 500 early in 2025. This milestone underscores SpaceX's dominance in reusable rocketry, a feat others have yet to replicate. Meanwhile, international competition intensifies. On November 21st, China released an animated preview of its crewed lunar mission, featuring its lunar rover Lanyue and operations on the moon. The video showcased astronauts deploying the rover and traversing pre-planned routes, highlighting the Wenchang Satellite Launch Center as a key hub for China's ambitions. As SpaceX advances, the global space race continues to heat up, driving innovation and progress on an unprecedented scale. China has updated progress on its Long March 10 rocket, lunar lander, crewed spacecraft, lunar suits, and related tests, reaffirming its goal of a crewed lunar mission by 2030. These advancements heightened the global space race, emphasizing the need for NASA and SpaceX to sustain their momentum. SpaceX, with Starship at the forefront, is pivotal in ensuring the United States maintains its lead in space exploration. NASA's Artemis program and SpaceX's ambitious lunar plans provide a clear strategy to stay ahead. But continued innovation and progress are essential. Recent successes with Falcon 9 and Starship's ongoing development lay a strong foundation to meet these challenges. As the competition intensifies, the need for adaptability and innovation remains critical. With SpaceX leading the charge, supported by NASA and other partners, the US is well positioned to dominate this era of space exploration. The next few years promise exciting developments as SpaceX drives humanity's reach into the cosmos to new heights, turning challenges into success. This has become a hallmark of SpaceX's journey. Flight 6 is yet another testament to this philosophy. While this mission is regarded as a success, particularly for the spacecraft, a few issues arose during the process. However, in true SpaceX fashion, these challenges present opportunities to further enhance the capabilities of their groundbreaking vehicle. So what exactly went wrong with the spacecraft during Flight 6? And how does SpaceX plan to address these issues to strengthen their colossal Starship even further? Flight 6 marks another significant milestone in SpaceX's mission to bring humanity closer to Mars. Building on the success of previous flights, SpaceX once again demonstrated its ability to achieve two-stage landings. While some debates persist around Super Heavy's performance, the progress with ship was undeniable. This time, instead of the explosive aftermath seen in Flight 5, only minor fires were observed after landing, a clear step forward. However, challenges remain, and these should be viewed as opportunities for further refinement and innovation. One notable issue during Flight 6 involved Starship S-31 undergoing severe thermal stress, resulting in deformation and discoloration on its surface. The deformation was particularly evident during the ascent. At T plus 47 seconds, everything appeared normal. But by 49 seconds, dents began to form and became increasingly visible as the flight progressed. SpaceX later shared images on social media that highlighted these deformations more clearly. Discoloration, on the other hand, was more apparent during re-entry and descent. Without the protective heat shields in some areas, portions of the spacecraft turned a blue-purple hue, a telltale sign of overheating. This discoloration was most noticeable when sunlight reflected off the affected areas near the end of the descent, and SpaceX's post-flight images confirmed these observations. So, what caused these issues? Before the flight, SpaceX deliberately removed over 2,000 heat tiles from S-31 to test its resilience and to prepare for the installation of future landing support systems. Additionally, the descent angle was adjusted to be steeper than usual, subjecting the spacecraft to more extreme conditions. During re-entry, temperatures often exceed 1,500 degrees Celsius. Without adequate heat shield protection and with a sharper re-entry angle, the stainless steel hull of S-31, made from 304L alloy, was exposed to severe stress. This steel, while durable, has a melting point below re-entry temperatures, leading to deformation and overheating. Another contributing factor may have been oxidation. The friction generated during atmospheric re-entry, combined with the high oxygen content of the atmosphere, likely caused the chromium, nickel, and carbon in the steel alloy to oxidize, further altering the material's color and structure. While these issues didn't compromise the mission's overall success, they present challenges for future iterations. SpaceX plans to install additional systems in areas affected by these stresses, and the durability of those components will be critical. The forward flap's performance in Flight 4 serves as a reminder of the vulnerability of protruding systems under extreme conditions. Moreover, thermal shock likely played a significant role in the observed changes. At liftoff, the ship's temperature is extremely low due to the presence of liquid oxygen and methane. As it ascends and experiences intense atmospheric friction, temperatures rise dramatically, peaking during re-entry. This is followed by a sudden drop when the ship lands in the ocean. These rapid temperature fluctuations challenge the structural integrity of even the most advanced materials. These stresses likely contributed to the post-landing failure of S-31's fairing, which exploded after landing despite the vehicle touching down safely, as Musk later revealed. SpaceX's relentless pursuit of innovation continues to drive Starship's evolution, with a key focus now turning toward crucial upgrades that will ensure the spacecraft's readiness for future missions, including journeys to Mars. Among these, the heat shield stands out as a vital area of development, safeguarding the spacecraft during the intense heat of atmospheric re-entry. No matter how advanced the materials used for Starship become, the heat shield will remain an indispensable element of its design. Fortunately, recent flights have shown encouraging progress in this area. Recovery images from these missions reveal that the new heat shield tiles are performing exceptionally well. These tiles, which were first implemented on prototypes like S-30 and possibly S-31, reflect improvements SpaceX has made following earlier flights. After Flight 4, Musk noted that the updated heat shields were twice as strong, incorporating an ablative layer to enhance durability. Furthermore, the frequency of tiles detaching during the flight has significantly decreased, showcasing SpaceX's iterative approach to problem-solving and design enhancement. However, the current heat shield system is not the end goal. As SpaceX transitions to Starship V2, more advanced upgrades are expected to further bolster its capabilities. These enhancements could debut as soon as Flight 7, offering a glimpse of a more resilient and efficient system. During the Flight 6 livestream, SpaceX hinted at tests for a new generation of heat shields, specifically designed for Mars missions. One of the biggest challenges remains creating a fully reusable heat shield. Musk has described this as the biggest technology challenge remaining for Starship. Among the potential solutions being considered is metallic shielding, which could be supplemented by ullage gas or liquid film cooling. This innovative system involves a layer of inert gases or liquids creating a protective barrier between the spacecraft's surface and the extreme heat of re-entry. Compared to ceramic tiles, metallic heat shields offer superior durability, resisting cracking and damage caused by thermal stress. However, this durability comes at the cost of increased mass, a trade-off SpaceX will need to address. Cooling systems are another promising avenue for improving thermal protection. Materials like methane or water could be used to regulate temperature and absorb excess heat, mitigating the risks of thermal shock. By reducing sudden temperature changes and heat spikes, these systems could provide an additional layer of protection for Starship during its most vulnerable phases of flight. However, each coolant material presents its own set of challenges, requiring meticulous testing and refinement to determine the optimal solution. A more immediate strategy to reduce thermal shock and enhance Starship's reusability involves shifting landings from the ocean to the Mechazilla tower. Ocean landings, while effective for early testing, complicate recovery efforts and can expose the spacecraft to rapid temperature changes that stress its components. In contrast, catching Starship with the Mechazilla arm would enable faster refurbishment and a shorter turnaround for future launches. What are your thoughts on SpaceX's recent advancements and the challenges they are working to overcome? Share your thoughts in the comments section down below, and don't forget to like, share, and subscribe to stay informed about SpaceX's groundbreaking progress. Now that we've concluded the Starship updates, let's shift our focus to the Falcon 9 and its recent NRO mission, NROL-126. This mission launched at 3:10 a.m. Eastern from SLC-4E in California, carrying payloads for the National Reconnaissance Office. It included 20 Starlink satellites and an unspecified number of government satellites, likely including 2 of SpaceX's Starshield satellites. The mission highlights SpaceX's critical role in supporting both commercial and government satellite deployments. For security reasons, the live stream of the launch was delayed until 46 seconds after liftoff. Later, SpaceX shared on social media, Falcon 9 launches the National Reconnaissance Office's NROL-126 mission and 20 Starlink satellites to orbit. This mission marks the 5th in the NRO's proliferated architecture of imaging satellites, a series jointly developed by SpaceX and Northrop Grumman. The previous 4 missions launched earlier this year in May, June, September, and October. Together, these efforts aim to build the largest government-run satellite constellation in history. Deployment of this constellation began in mid-2023 using a variety of rockets, including ULA's Delta IV Heavy and Atlas V and Rocket Lab's Electron. However, SpaceX's Falcon 9 has since taken the lead and will likely remain the backbone of future launches. Currently, 3 more NROL missions are scheduled for December of 2024, emphasizing the importance of the Falcon 9 in meeting the government's satellite deployment needs. Its reliability and cost-effectiveness make it the preferred option for missions under the National Security Space Launch Program. The Falcon 9 also achieved several milestones with this mission. It marked the first flight for booster B-1088, the 11th successful landing of the Of Course I Still Love You drone ship, and the 377th overall landing for SpaceX. Most notably, it was the 100th successful launch from Pad SLC-4E in California, a meaningful achievement given the ongoing challenges SpaceX faces with local regulations regarding rocket launches in the region. As 2024 nears its close, there's still time for SpaceX to set even more records. With their impressive momentum, it will be exciting to see what milestones they achieve before the year ends. The next phase of Starship development is upon us, and it's nothing short of exciting. We're seeing advancements across the board: new Starship versions, refined production techniques, upgraded test systems, innovative launch processes, and so much more. Yet amidst all this progress, one crucial system remains somewhat enigmatic: Raptor 3. What upgrades are being made to this powerful engine? When will it be implemented? Elon Musk has dropped some intriguing hints, making bold statements that have left scientists buzzing with anticipation. The final month of the year has arrived, and SpaceX is already gearing up for the next major milestone. While the next Starship flight is projected for early next year, 2023 has been a remarkable year for SpaceX's development journey. 2024 has been a remarkable year for SpaceX's development journey. With 4 Starship flights completed, the company has made significant strides in validating the performance and reliability of its Raptor engines. From smooth activations and shutdowns to precise navigation, acceleration, and deceleration, the Raptors have demonstrated their capabilities with remarkable consistency. One of the year's most notable achievements was Booster 12's successful landing using the innovative Mechazilla arms, a feat that showcased the potential of SpaceX's unique recovery systems. However, achieving reliability with the Raptor engine is far from SpaceX's ultimate goal. The company's ambitions stretch far beyond, as evidenced by the unveiling of Starship V2 and the ongoing development of Raptor 3. Dubbed by Elon Musk as a work of art, the Raptor 3 engine is poised to redefine what is possible in rocket propulsion. Since its introduction in August, Raptor 3 has been a topic of great excitement and anticipation. Musk recently described the engine as truly sublime engineering, adding that its capabilities are so advanced that even seasoned veterans of the space industry initially deemed them impossible. One of the most thrilling aspects of Raptor 3 is its enhanced thrust capability, which Musk detailed in a recent update. According to Musk, Raptor 3 aims to deliver an incredible 300 tons of thrust per engine at liftoff. With 33 engines powering Starship's first stage, this translates to nearly 10,000 tons of combined thrust, approximately 3 times the power of NASA's legendary Saturn V rocket. To put this into perspective, Raptor 3 was already impressive with a maximum thrust of 269 tons, and SpaceX initially announced Raptor 3 would reach 280 tons. However, Musk's revelation of a 300-ton capability pushes the boundaries even further. This increase in thrust is not just a marginal improvement, it has profound implications for Starship's performance. The new thrust levels bring Starship closer to achieving its goal of transporting larger payloads to orbit and beyond, including missions to the Moon and Mars. Additionally, with Musk hinting at future engine versions capable of delivering 330 tons of thrust, it's clear that SpaceX's long-term vision includes even more powerful and efficient propulsion systems. While thrust is a critical metric, it's only one piece of the puzzle. A truly revolutionary engine must also excel in efficiency, reliability, and manufacturability. Raptor 3 is designed with these priorities in mind. Musk highlighted the extraordinary effort required to simplify the engine's design. The amount of work required to simplify the Raptor engine, internalize secondary flow paths, and add regenerative cooling for exposed components was staggering. This simplification process represents a major leap forward in rocket engine design, as it reduces complexity while enhancing performance. A key aspect of Raptor 3's simplicity is the removal of flanges and screws, which are traditionally prone to issues like leaks and heat accumulation. These components have been replaced with welded structures which are more robust and reliable. Additionally, the integration of systems has enabled the removal of the engine heat shield, resulting in significant weight savings. To compensate, Raptor 3 features an advanced regenerative cooling system that protects the engine from the intense heat and pressure of operation. These design changes not only improve performance but also make production more efficient. With Raptor 2, SpaceX reached a production rate of 1 engine per day, a remarkable achievement in its own right. The simplified Raptor 3 design could enable even faster production rates, especially with the integration of advanced 3D printing technologies. Faster production reduces costs and ensures a steady supply of engines to support SpaceX's ambitious launch schedule. Simplicity also brings benefits to post-launch operations. A less complex engine is easier to refurbish, reducing turnaround times and enabling the high-frequency launches required for Starship's reusability goals. This aligns with SpaceX's broader strategy of lowering costs and increasing accessibility to space. Despite its potential, the big question on everyone's mind is when will Raptor 3 make its operational debut? During the Flight 6 launch, Musk suggested that Raptor 3 would be introduced sometime in 2025.
A big version of Increase that'll be flying next year.
However, details about its production progress remain limited, leaving room for speculation. Many observers initially believed that Raptor 3 would debut with Starship V2 starting with Ship 33 on Flight 7. However, SpaceX opted to equip the first V2 prototype with Raptor 2 engines, indicating that Raptor 3 was not yet ready for flight. Looking ahead, it seems unlikely that Raptor 3 will appear in the next few flights. SpaceX's upcoming missions include critical milestones, such as the catching of the Starship upper stage with the Mechazilla arms. For such high-stakes operations, SpaceX may prioritize the proven reliability of Raptor 2. As a result, Raptor 3 might not make its debut until after these missions are successfully completed. Based on current timelines, a realistic scenario for Raptor 3's debut could be around Flight 9. This would allow SpaceX to finalize production and conduct thorough testing before integrating the new engines into an operational mission. Of course, SpaceX is known for its rapid development pace, so the timeline could shift depending on progress. Whenever it arrives, Raptor 3 is set to be a game changer. Its combination of increased thrust, simplified design, and enhanced reliability will enable Starship to push the boundaries of space exploration. From delivering cargo and crew to the Moon and Mars to supporting the construction of a multiplanetary civilization, the potential applications of this engine are virtually limitless. As we anticipate Raptor 3's debut, it's a perfect time to reflect on SpaceX's journey. Their iterative approach, refining each version through testing, has driven progress from Raptor 1 to Raptor 2 and now to Raptor 3. Each iteration represents leaps in performance, cost efficiency, and manufacturability. Raptor 3 marks a pivotal moment for SpaceX and the future of space exploration. With nearly 10,000 tons of thrust, groundbreaking efficiency, and a streamlined design, this engine isn't just a technological achievement, it embodies humanity's limitless potential when innovation and ambition unite. Get ready to witness history, share your excitement, follow for updates, and join SpaceX as they push the boundaries of what's possible. The future is here, and Raptor 3 is leading the way. But of course, the introduction of Raptor 3 is merely the opening chapter in the next era of SpaceX's Starship program. As SpaceX pushes the boundaries of rocket design and performance, Musk has ambitious plans for future iterations. The goal is to increase the thrust of the Raptor engine to an astonishing 330 tons, resulting in a total liftoff thrust exceeding 10,000 tons. Such a feat would establish this as the most powerful rocket ever developed. While specific design details for these more advanced engines remained undisclosed, it is anticipated that they will maintain SpaceX's trend of simplifying and optimizing their designs. According to plans outlined in the Starship Florida project, these upgrades are likely to coincide with Starship V3, a version projected to stand an impressive 150 meters tall. This iteration could become the cornerstone of SpaceX's Mars missions, which Elon Musk has optimistically suggested may commence within the next 2 years. And achievements, inviting us all to imagine what lies ahead in this grand adventure. Turning to recent developments in the global space race, China's land space achieved a significant milestone with the launch of its upgraded Zhuque-2E rocket. The launch occurred at 9 p.m. Eastern from the Dongfeng Commercial Space Innovation Test Area at the Jiuquan Satellite Launch Center. This mission successfully deployed 2 Guangquan satellites into orbit, marking a major success for the company. The Zhuque-2E is an advanced version of Landspace's methane-powered rocket. Measuring 47.3 meters in length and 3.35 meters in diameter, it boasts a payload capacity of 4 tons to sun-synchronous orbit at 500 kilometers. The Zhuque-2 program had a challenging start with a failed debut in December of 2022. However, the subsequent 2 missions were successful, making the Zhuque-2 the first methane-fueled rocket to reach orbit and deliver a payload. This progress positions Landspace as a leader among Chinese private aerospace companies, particularly those often labeled as SpaceX copycats. The company plans another Zhuque-2E mission in December and is already setting its sights on the Zhuque-3, a stainless steel reusable rocket resembling SpaceX's Starship. Landspace conducted a test flight for Zhuque-3's launch and landing system in September, with a full launch anticipated by 2025. Despite its strides, Landspace's achievements do not yet rival SpaceX's Starship. While the Zhuque-2 earned the title of the first methane rocket to reach orbit, Starship has already moved far beyond, achieving orbit, controlled landings, and recovery of its super heavy booster. With ongoing advancements, such as mastering 2-stage landings using the Mechazilla system, Starship continues to set a standard unmatched by competitors. The methane rocket sector, however, is heating up. In addition to Zhuque-2 and Starship, other players are entering the fray, including the Blue Origin, New Glenn, and the ULA Vulcan Centaur. This competition promises an exciting race to establish dominance in this emerging rocket class. Who will lead the charge? For now, SpaceX remains far ahead, but the coming years will undoubtedly reveal the next chapter in this dynamic field. Unpredictable. That's the best word to describe the Falcon Heavy, SpaceX's quiet warrior, as it silences skeptics and secures a lucrative contract worth hundreds of millions of dollars to launch NASA's billion-dollar mission. More importantly, this time, Falcon Heavy will play a pivotal role in humanity's quest to explore and discover new life within the solar system. So what is on the horizon? We'll dive into the exciting prospects of this mission, and then shift our focus to the Falcon 9 update, including progress on the Blue Ghost lunar mission and its impressive new reuse record. After a booming 2023 with 5 successful flights, Falcon Heavy has been less active this year with only 2 flights. This has sparked some concerns about the future of the rocket, but rest assured, Falcon Heavy remains a critical asset for both SpaceX and the aerospace industry for at least the next few years. This was reaffirmed when NASA officially selected Falcon Heavy to launch the Dragonfly mission. Dragonfly is a rotorcraft designed to explore Titan, Saturn's second largest moon, and it carries a mission value of up to $3.35 billion US. On November 25th, SpaceX confirmed the news via X, stating Falcon Heavy was selected by NASA to launch the Dragonfly mission to Saturn's moon Titan. NASA's own announcement followed shortly after with a statement saying NASA has selected SpaceX to launch Dragonfly. The agency provided additional details about the Dragonfly mission, highlighting the rotorcraft's capabilities. NASA's Dragonfly mission is a rotorcraft that has 8 rotors and flies like a large drone. It'll explore Saturn's moon Titan, examining dozens of promised locations. Titan is the second largest moon in our solar system and has a nitrogen-based atmosphere that is 4 times denser than Earth's. Dragonfly will help advance astrobiology and our search for the building blocks of life. In addition, NASA clarified the terms of agreement, stating that its partnership with SpaceX is based on a firm, fixed-price contract worth approximately $256.6 million. This includes launch services and other mission-related costs. The Dragonfly mission is scheduled to launch between July 5th and July 25th, 2028, from LC-39A at Kennedy Space Center. NASA described Dragonfly as the 4th mission in NASA's New Frontiers program, managed by the Marshall Space Flight Center in Huntsville, Alabama, and overseen by the Science Mission Directorate in Washington. This mission represents a significant milestone in space exploration and will advance humanity's search for life beyond Earth. Weighing in at 450 kilograms, Dragonfly is designed to explore Titan's surface and atmosphere. Its primary mission tasks include sampling materials, determining surface composition in different geological environments, and advancing the search for the building blocks of life. What sets Dragonfly apart from previous space missions is its novel approach to exploration. The rotorcraft will travel repeatedly between dozens of promising locations, collecting samples and characterizing the habitability of Titan. Through these efforts, Dragonfly will help scientists understand the evolution of prebiotic chemistry on Titan. SpaceX, in a tweet, further explained the mission's scope. The nuclear-powered rotorcraft will look for prebiotic chemical processes common on both Titan and on Earth before life developed. Titan, being the second largest moon in our solar system, has an atmosphere 4 times thicker than Earth's, composed mostly of nitrogen. Titan's rich carbon content and potential for liquid water make it an intriguing target for scientists searching for signs of life or conditions conducive to life. The importance of the Dragonfly mission cannot be overstated. NASA's update emphasized Titan's potential for harboring life, with its thick atmosphere and chemical resources potentially serving as the building blocks for life. NASA's Launch Services Program at the agency's Kennedy Space Center is responsible for managing the launch service. Managed for NASA at Johns Hopkins Applied Physics Laboratory in Laurel, Maryland, the Dragonfly team comprises scientists, engineers, technologists, managers, and more deep experience on missions that have explored the solar systems from the Sun to Pluto and beyond, the agency stated. The fact that Falcon Heavy has been selected for such a crucial mission speaks volumes about its reliability. While Falcon 9 may dominate the launch scene, Falcon Heavy continues to hold a vital role in handling the heaviest payloads and the most complex missions. So far, Falcon Heavy has successfully launched 11 missions, a relatively small number compared to Falcon 9, but its success rate remains impeccable. Notably, Falcon Heavy has handled high-profile missions including Jupiter 3, Europa Clipper, and Psyche. Beyond the Dragonfly mission, Falcon Heavy is set to carry out several other significant missions in the coming years. These include the 2 Griffin lunar missions in 2025 and 2026, and NASA's PPE and HALO missions as part of the Lunar Gateway program in 2027. Additionally, Falcon Heavy has played a key role in the United States Space Force's National Security Space Launch Program. Despite recent fluctuations in its flight schedule, Falcon Heavy's role in the space industry is not in decline. On the contrary, its importance is poised to grow. The Dragonfly mission, with its potential to significantly expand humanity's understanding of Titan and astrobiology, will be one of the Falcon Heavy's most important launches. This mission is an important step toward broadening our understanding of the universe and may lead to groundbreaking discoveries in the search for life beyond Earth. As we look toward the future, the Falcon Heavy will continue to serve as an essential tool in SpaceX's arsenal, enabling it to tackle an array of ambitious space missions. With Falcon Heavy playing a key role in both governmental and commercial space endeavors, SpaceX is well positioned to continue leading the charge in space exploration. Let's show our support for this pivotal milestone by replying "Heavy Fly" in the comments section down below, marking this historic event and wishing the Dragonfly mission nothing but success. Finally, I want to thank you for subscribing to my channel, as it greatly helps us maintain a healthy subscriber-to-viewer ratio. Still, we have a high number of unsubscribed viewers, so please consider subscribing to stay updated on the latest developments in space exploration. Your support helps us grow and continue providing you with timely updates on SpaceX and the aerospace industry. Thank you. Indeed, the power of SpaceX's orbital fleet is unquestionable, and while the Falcon Heavy has made significant strides, the Falcon 9 continues to evolve and prove its value. Notably, Firefly, the company responsible for the Blue Ghost lunar lander, has announced that they are ready to launch the mission in mid-January. This announcement follows the successful completion of testing at NASA's Jet Propulsion Laboratory in October. The mission will launch on a Falcon 9 rocket from Florida, a significant step in Firefly's ongoing development. In a company statement, Jason Kim, CEO of Firefly, expressed his confidence in the mission's success. Blue Ghost aced environmental testing and proved the lander is performing 100% as expected. While we know there will be more challenges ahead, I'm confident this team has what it takes to softly touch down on the lunar surface and nail this mission. Originally, the mission was scheduled for the fourth quarter of 2024, but the exact launch date had not been specified. However, with the updated schedule, the launch time frame has become clearer, marking an important step forward. SpaceX is finalizing arrangements for the mission, which reflects the growing confidence in this collaboration. The Blue Ghost lunar lander is part of a task order awarded by NASA to Firefly in February of 2021, valued at $93.3 million. As part of NASA's Commercial Lunar Payload Services program, the Blue Ghost mission will carry 10 NASA payloads to the moon. This mission, named Ghost Rider in the Sky, will span 2 months, including 45 days of transit from the Earth to the moon. The lander will land near Mons Latrell, a volcanic region in Mare Crisium, on the moon's northeastern near side. This period will include 1 lunar day, which is equivalent to 2 Earth weeks, and a few hours of lunar night. Originally planned for later this year, Blue Ghost's launch, along with 2 other lunar missions, iSpace's Mission 2 and Intuitive Machines IM-2, has now been moved to early next year. Crucially, all 3 missions will be launched aboard the Falcon 9, demonstrating the rocket's reliability and versatility in handling critical lunar missions. SpaceX's Falcon 9 continues to prove its importance, further solidifying its role as a foundational element in future human missions to the moon aboard the Starship HLS in the coming years. Speaking of Falcon 9's capabilities, the rocket has just hit another major milestone. On 25th, SpaceX launched a Falcon 9 rocket from SLC-40, Florida, carrying 23 Starlink satellites into orbit. This launch marked the 401st mission for the Falcon 9, following its 400th launch on November 24th. It also marked SpaceX's 116th mission overall. However, the real highlight of this mission was the performance of its booster B-1080. Just over 8 minutes after liftoff, the booster successfully landed on the GRTI drone ship, marking its 13th landing, the 99th landing on the GRTI drone ship, and the 374th landing overall in SpaceX's history. This achievement is a testament to the success of SpaceX's reusability strategy. Even more notable, B-1080 set a new turnaround record by being ready for reuse just 13.5 days after its previous launch on November 11th. This new record is 1 week faster than the previous turnaround record of 21 days, set by the retired booster B-1062 in April of 2022. The reduction in refurbishment time underscores SpaceX's efficient approach to rocket reusability, allowing faster turnarounds and meeting the growing demand for space missions. This milestone brings SpaceX closer to its goal of having each Falcon 9 booster complete 40 flights, revolutionizing space access and lowering costs. Falcon 9's reusability advancements will support key missions like the Blue Ghost lunar lander and future exploration projects. With its reliability and quick turnaround, Falcon 9 remains vital to SpaceX's success and its leadership in shaping the future of space. As SpaceX continues to break records, we can expect even more milestones in the near future. Have you ever imagined a collaboration between rival companies SpaceX and Blue Origin? While such a partnership seems impossible, on the other side of the world, China has seemingly made it happen through imitation. A Chinese company has introduced a rocket that blends elements of both SpaceX and Blue Origin designs. So what does this new rocket look like? Is it a groundbreaking innovation, or just another attempt by China to catch up with SpaceX and the United States? Additionally, we'll provide an update on Europe's Vega C schedule. China has been developing rapidly for many years, striving to catch up with the United States. One of the strategies fueling this growth has been adopting and adapting the best systems worldwide. Among these, SpaceX has undoubtedly been the most imitated. Evidence of China's imitation spans nearly every aspect of aerospace technology: rockets, spacecraft, launch systems, fuels, materials, and more. Recently, another striking example of this trend emerged. A private company called Nayuta Space, in cooperation with an organization known as Aerospace Propulsion, unveiled a new rocket system dubbed the Space Chaser 1, or Sunniao 1. This rocket is a clear combination of concepts from SpaceX and Blue Origin. Why do I make this claim? Let's start by examining the visual similarities. At first glance, the overall design of Space Chaser 1 closely resembles SpaceX's Falcon 9. Its black and white exterior immediately mirrors Falcon 9's iconic appearance. The two-stage rocket has a similar height-to-diameter ratio, along with a fairing on top for payload deployment. In terms of specifications, Space Chaser 1 measures 67.3 meters in height and 3.8 meters in diameter, with a liftoff thrust of 450 tons, slightly less powerful than Falcon 9. The rocket's first stage is powered by 9 Kang-Long 1 engines, which provide 70 tons of thrust each. The second stage uses a single Kang-Long 1 vacuum engine. This configuration mirrors Falcon 9's 9-engine first stage and single-engine second stage. Additionally, Space Chaser 1 uses Methalox fuel and incorporates stainless steel in its construction, much like SpaceX's Starship. With these features, the rocket is designed to deliver up to 10 tons to low Earth orbit when reused. However, there's a twist. While the rocket is heavily inspired by Falcon 9, it also borrows elements from Blue Origin's designs. Instead of using grid fins for navigation and landing as Falcon 9 does, Space Chaser 1 employs steering fins, similar to Blue Origin's New Glenn rocket. A more striking difference is the absence of landing legs, making Space Chaser 1's recovery approach more akin to SpaceX's Starship than Falcon 9. Without landing legs, the rocket relies on a catching system involving mechanical arms mounted on a tower. This is essentially the same concept as Starship's Mechazilla arm system. According to published mission charts, Space Chaser 1's launch, separation, landing, and recovery process closely follows Starship's framework. In addition to these design features, Nayuta Space highlighted an innovative technology called Pneumatic recovery. The company claims this approach represents a new era of rocket recovery technology 2.0, aimed at enabling cost-effective, reusable launches for people and cargo. Unlike Falcon 9, which relies on its engines for deceleration during landing, Space Chaser 1 will use aerodynamic principles to rapidly decelerate. By increasing the rocket's drag-to-mass ratio, it achieves a controlled descent without engine-powered braking. Nayuta Space compares this technique to NASA's Space Shuttle and SpaceX's Starship, admitting their system draws inspiration from both. Notably, the company plans to use this recovery method for both the first and second stages of Space Chaser 1, achieving full recovery and complete reusability. This represents a bold ambition, as very few systems worldwide aim for 100% recovery. In their announcement, Nayuta Space expressed confidence in the technology's potential, stating, "In the future, pneumatic recovery technology will play a key role in enabling people and cargo to travel freely between the Earth and the sky. It will contribute to the development of commercial spaceflight by making it a civilian means of transportation." Interestingly, Nayuta Space also included detailed analyses comparing their rocket to SpaceX's Starship and Falcon 9. These comparisons aim to demonstrate the advantages of their chosen recovery method. However, it's clear that Space Chaser 1's design heavily borrows from SpaceX's established innovations. Whether this approach leads to meaningful breakthroughs or merely serves as another example of replication remains to be seen. Will Space Chaser 1 succeed? That's the million-dollar question. On paper, the rocket's specifications and reusability goals are impressive. However, developing reliable systems for launch and recovery requires more than copying existing designs. It demands engineering precision, rigorous testing, and operational expertise. SpaceX's success stems not just from its innovative ideas, but also from years of iterative development and hard-earned experience. Let me know what you think about the rocket. Will it succeed or fail? Type S for success or F for failure in the comments section down below. And don't forget to like and subscribe to our channel to keep up with all things SpaceX and aerospace. Now, in my opinion, while this plan appears ambitious, it is unlikely to surpass SpaceX and may ultimately fail. First, combining elements of SpaceX and Blue Origin rocket designs seems impractical. For instance, using a steering fin system for tower landing is less effective than SpaceX's grid fins. Grid fins excel during the final navigation phase by ensuring precise orientation and stability, especially when transitioning to vertical alignment for a catch by the chopsticks. In contrast, steering fins, as seen in Blue Origin's New Glenn, are better suited for conventional landing systems or drone ship recoveries, not complex tower captures. Second, attempting a catch mechanism for a smaller, less powerful rocket seems unnecessary and overly complex. This added complexity increases the risk of failure and lengthens refurbishment times for the launch pad, negating the efficiency benefits Nayuta Space aims to achieve. Ironically, what they perceive as innovative strengths may ultimately hinder progress due to poor execution and technological inexperience. Copying SpaceX's ideas might seem straightforward, but in reality, it is an immense challenge. Many companies that attempted to replicate SpaceX's success have failed, often before their rockets even reached the launch pad. While these ventures might initially attract investments, a single failure often leads to investor withdrawal and bankruptcy. Great Space risks the same fate. Additionally, copying multiple designs and attempting to merge them into a single system highlights a lack of original thought. This approach not only undermines long-term innovation, but also makes these rockets less adaptable to unforeseen challenges. Chinese companies like Great Space seem more focused on imitating success than developing unique solutions, leaving them vulnerable to stagnation and setbacks. In conclusion, despite Great Space's efforts to showcase the potential of its plan and its determination to outdo the original concepts, the attempt feels more like an act of desperation. Time will tell if these plans lead to success or confirm the inherent flaws in their strategy. Now let's shift our focus to Europe and examine the challenges surrounding Vega C's return to flight mission. After nearly 2 days of delays, Vega C is preparing to launch the Sentinel-1C spacecraft. However, the mission has experienced another slight postponement. Originally scheduled for December 3rd, the launch is now set for December 4th. Arianespace confirmed the delay was necessary to complete additional checks and activities on the Flight VV-25 Vega C launcher. The new launch attempt is scheduled for December 4th at 6:20 p.m. Kourou time, or 9:20 p.m. UTC, or 4:20 p.m. Eastern. Despite this, Arianespace has assured that the payload remains in stable and safe condition. Stefan Israel, chief executive of Arianespace, downplayed the significance of the delay, stating, "I don't think there is a lot to elaborate on. We are talking about something which I would say has very limited consequences." Meanwhile, Giulio Ranzo, chief executive of Avio, emphasized their commitment to thorough testing. "When we see something that we are not completely satisfied with, we love to intervene and conduct more checks." Both leaders expressed confidence in the upcoming Vega C mission and highlighted their extensive preparations and system upgrades. Ranzo also noted significant progress in the design and manufacturing of the Zefiro 40 engine, a crucial component of Vega C. The 2 tests that we have performed and joint work with the European Space Agency has revealed a very good performance of the Zefiro 40 with the new design, he shared. He further explained, "We have taken the time to increase the robustness in the design and, more importantly, in the manufacturing of the launcher over the last couple of years to make sure it will be fully robust and flightworthy." The return of Vega C is a pivotal moment for Europe, especially in conjunction with the upcoming first flight of Ariane 6, planned for July. These missions are expected to address what has been referred to as Europe's launcher crisis. Tony Tolker-Nielsen, ESA's Director of Space Transportation, underscored the mission's importance. "This is an important step for Europe's independent access to space, or let's say re-establishment of this independent access to space." However, challenges remain. I remain skeptical that Vega C will meet its revised timeline, and the ongoing delays with both Vega C and Ariane 6 highlight broader issues. These setbacks have cost ESA critical opportunities, particularly as European contracts increasingly shift towards SpaceX, whose rockets continue to operate reliably across the Atlantic. Without substantial progress, Europe faces an uphill battle to reclaim its position in the space race. Let's see how Europe navigates these challenges and whether Vega C can truly deliver on its promise. Up We Go has now transformed into Up and Down, capturing the turbulent journey of New Glenn, Blue Origin's most ambitious project. Despite high hopes, this colossal rocket has yet to fly, let alone undergo testing. What's causing the delay? When will it finally launch? While SpaceX rockets break records and achieve unprecedented milestones, New Glenn remains grounded, its future uncertain, and, obviously, collecting dust. As 2024 nears its end, after years of preparation, late October brought long-awaited progress. The BE-4 engine, the rocket's centerpiece, was officially installed, and by early November, New Glenn's second stage was mated to its first. Shortly afterward, the payload fairing was stacked, and by November 21st, New Glenn stood tall on launch pad LC-36, marking a major step toward its integrated hot fire test. This milestone seemed to signify a turning point. However, progress quickly faltered, casting doubt on New Glenn's readiness. After being rolled out to the pad, the rocket underwent no immediate testing. Instead, it was lowered back down on November 26th, only to be restacked the same day. By December 1st, New Glenn was lowered again with no signs of significant activity or testing during this period. More than 10 days passed without any meaningful updates, leaving industry watchers confused and concerned about the rocket's future. These delays and erratic movements suggest underlying issues with either the rocket itself or the launch support systems. If the problem lies with the vehicle, it could stem from the BE-4 engines, hardware inconsistencies, or complications with the fueling system. Alternatively, the launch infrastructure may be at fault, potentially due to problems with fuel handling, connections between the rocket and ground equipment, or safety protocols. Without an official explanation from Blue Origin, speculation abounds, but either scenario underscores a lack of readiness that tarnishes the company's image. The situation has amplified skepticism about Blue Origin's ability to compete in the modern space race. Musk, CEO of SpaceX, hasn't missed the opportunity to highlight the disparity. On November 21st, the same day New Glenn was rolled out to the pad, Musk tweeted, "How time flies," alongside an image of himself and Jeff Bezos from a meeting 2 decades ago. Musk's caption referenced advice he had given Bezos at the time, which he claimed had been ignored. Criticism of Blue Origin's work ethic isn't new. In 2018, Jason Davis, a former Blue Origin official, remarked, "Blue is kind of lazy compared to SpaceX." Today, that sentiment resonates even more as SpaceX continues to achieve significant milestones. In the last quarter alone, SpaceX completed 2 Starship missions, underscoring its dominance while New Glenn remains grounded. The delays surrounding New Glenn are particularly troubling because of the stakes involved. Several high-profile missions depend on its success, and any further setbacks could have far-reaching consequences. For example, Blue Origin is slated to launch Escapade, NASA's Mars spacecraft, and the company's proprietary Blue Ring mission. Originally planned for 2024, both have now been delayed, with Escapade pushed to early 2025. The time-sensitive nature of the Escapade mission, due to the limited launch window to Mars every 26 months, makes these delays even more critical. Additionally, Blue Origin faces mounting pressure from the FAA. According to journalist Christian Davenport, New Glenn has yet to secure an FAA launch license, a process that typically requires rigorous testing and significant lead time. Considering the FAA's strict approach illustrated by their handling of SpaceX's Starship, it seems unlikely that New Glenn will obtain certification in the near term. Even if Blue Origin completes all necessary tests soon, the timeline for licensing and scheduling a launch could easily slip into mid-2025. The consequences of these delays ripple beyond New Glenn's inaugural mission. Blue Origin was awarded contracts for significant projects, including Amazon's Kuiper satellite program and the USSF's National Security Space Launch Phase 3 initiative. Both programs come with high stakes. For instance, the Kuiper satellite missions are critical to Amazon's plans to compete with SpaceX's Starlink, and any backlog would reflect poorly on both Blue Origin and Jeff Bezos, who also founded Amazon. Similarly, the NSSL program involves government and military launches, where reliability and timelines are paramount. Delays here could damage Blue Origin's credibility with government partners. The most pressing challenge, however, lies in New Glenn's role in NASA's Artemis program. As part of Artemis 5, New Glenn is expected to launch a crew mission to the moon following SpaceX's scheduled missions in 2026 and 2028. With international competitors like China ramping up their lunar ambitions, failure is not an option. Yet with its current pace, Blue Origin risks falling further behind, potentially jeopardizing its involvement in these landmark missions. Looking ahead, Blue Origin must not only complete New Glenn's first flight, but also demonstrate reliability and scalability to handle the ambitious tasks it has committed to. This includes missions tied to the Artemis program, Kuiper satellites, and the NSSL initiative, all of which require a consistent cadence of launches. Failure to deliver could lead to Blue Origin being sidelined in favor of more reliable providers like SpaceX or ULA. For Blue Origin, 2024 was meant to be a breakthrough year with multiple New Glenn launches. Instead, the year is ending with mounting doubts about whether the rocket will ever leave the ground. If Blue Origin cannot resolve its challenges quickly, it risks irreparable damage to its reputation and partnerships. So the big question remains, will New Glenn finally fly, or will it continue to collect dust while SpaceX solidifies its dominance? Share your thoughts in the comment section down below. Do you think Blue Origin can turn this around, or is it too late? Don't forget to like and subscribe for more updates on the evolving space race. Indeed, New Glenn finds itself inevitably compared to SpaceX's Starship once more. Not long ago, New Glenn seemed to be making promising strides, especially as the FAA's delays on Starship appeared to be leveling the playing field. Some speculated that New Glenn might even launch before Starship, posing a formidable challenge to SpaceX, including myself. Over a month ago, I asked which would launch first, New Glenn's inaugural flight or Starship's Flight 5. As Starship surged ahead, the question shifted to New Glenn versus Flight 6. However, it now seems I overestimated Blue Origin's progress. Despite favorable conditions, Blue Origin's apparent inability to move forward has kept New Glenn grounded while Starship continues to soar. Recently, SpaceX announced that Starship's Flight 7 is scheduled for the 11th of January, the beginning of 2025. Musk also teased plans to attempt a mid-air ship catch as early as Flight 8. Can New Glenn launch before those milestones? Let me know in the comments down below. While New Glenn stagnates, Starship's development pace is accelerating. The rapid turnaround between Flight 5 and 6 is just one example of SpaceX's operational efficiency. With the FAA reportedly considering permitting up to 25 Starship launches next year, 2024 could be even more explosive for SpaceX. The FAA itself may undergo reforms to streamline its licensing procedures, further removing barriers for Starship. If these reforms take effect, SpaceX will likely widen the gap, leaving Blue Origin even further behind. Even then, Blue Origin's struggles extend beyond New Glenn's initial launch. The company faces numerous high-stakes challenges across multiple projects. Recently, NASA assigned both Blue Origin and SpaceX the task of developing cargo versions of their lunar landers for delivering pressurized rovers and habitats to the moon in the early 2030s. For SpaceX, this means adapting Starship. For Blue Origin, it means evolving its Blue Moon lander. NASA has already outlined specific missions for each company. Lisa Watson-Morgan, program manager for the Human Landing System at NASA's Marshall Space Flight Center, noted, based on current design and development progress for both crew and cargo landers and the Artemis mission schedules for the crew lander versions, NASA assigned a pressurized rover mission for SpaceX and a lunar habitat delivery for Blue Origin. However, Blue Origin's aspirations face a significant obstacle. New Glenn has yet to reach orbit. Without a proven vehicle, achieving these lofty goals remains uncertain. Beyond the Lunar Lander program, Blue Origin is involved in other critical initiatives. For instance, it is one of the launch providers for Amazon's Kuiper satellite constellation. While this contract might seem like a guaranteed win, given Amazon's ties to Jeff Bezos, delays in New Glenn's development could lead to significant backlogs for the Kuiper system. Similarly, Blue Origin was recently selected for Phase 3 of the USSF's National Security Space Launch Program, a prestigious project critical to U.S. government and military operations. Unlike commercial ventures, delays here are unacceptable, as evidenced by ULA's ongoing challenges with mission backlogs. Most importantly, New Glenn is slated to support Artemis 5, a crewed lunar mission, scheduled after SpaceX's Artemis 3 and 4 in 2026 and 2028. With China gearing up for its own lunar missions during this time frame, failure is not an option for Blue Origin. Yet the current reality paints a bleak picture. New Glenn shows no tangible signs of being ready to handle these critical responsibilities. If progress does not accelerate, Blue Origin risks losing its place in these key projects, a potential embarrassment that could cause lasting damage to its reputation. In addition to what I said at the beginning, the phrase, "so close I can almost taste it," can easily turn into "so far I can only dream of it" for Blue Origin and New Glenn. Only time will tell whether they can rise to the challenge or falter before the race even begins. Let's just wait and see what steps Blue Origin takes next to silence the skeptics, or if they concede the game entirely. In any case, folks, that's about it for today's episode. Thank you so much for tuning in, and as always, this has been Kevin from Great SpaceX, along with my chickens, if you could hear them in the background. And until next time, keep looking up.